There are a wide range of gemstones used in jewelry, with each having its own characteristic color, or in some cases a range of colors. The origin of these colors has a chemical basis, and the precise color can vary depending on the chemical composition of the gemstone. Interestingly, many minerals are actually colorless in their pure form, and it is the inclusion of impurities in their structure which leads to their coloration. Generally speaking, we observe an object as colored when it absorbs some wavelengths of visible light, but not others. Different colors of light will have different wavelengths, so the exact wavelengths that are absorbed will affect the color that the object appears. For an example, an object that absorbs all wavelengths of visible light that pass through it but does not absorb red light will appear red. Why does this absorption of light occur in the first place? This is dependent on the elements present in the structure of the gemstone. Some elements don't lead to the absorption of visible light. For example, compounds containing metals from group 1 in the periodic table are commonly colorless. Conversely, the transition metals, the large group of metals in the center of the periodic table, are capable of absorbing colored light. Transition metals have this capability because they have electrons in d orbitals. Orbitals are essentially regions of space around an atom in which electrons can be found. They can have different shapes and energy levels. The d orbitals in transition elements are partially filled, and this means the unpaired electrons therein are capable of absorbing visible light in order to promote the electrons to a higher energy level. When they do this, the wavelength of light they absorb is removed from the light completely. They later fall back down from this excited state, releasing the excess energy as heat. Different transition metals are capable of absorbing different wavelengths of visible light, thus giving the wide range of colors seen in gemstones. The transition metals may be a part of the chemical formula of the mineral, or they may be present in the mineral as impurities. Even small amounts of these transition metal impurities, where a transition metal atom sits in the place of another atom, which would usually occupy that position in the structure, can lead to an intense coloration.
We decided to do a short experiment growing our own crystals. You can use a variety of different ingredients that will determine your crystal shape and size. We used Epsom salt, which will typically yield smaller shard-like crystals. Materials needed are clean glass jar, Epsom salt, food coloring, we used yellow, water, a measuring cup, chopstick or pencil, string, and a microwave. First, measure a 1:1 water to Epsom salt ratio. Place the salt in the glass jar. Next, heat water and microwave for 45 seconds. After water is heated, add your choice of food coloring. Then pour water into jar with salt. Tie the string onto chopstick or pencil and dangle string into mixture, letting the chopstick lay over mouth of jar. After the salt is dissolved, you can store the jar in the fridge to accelerate crystal growth. We let ours sit out a few days and were left with a pretty decent crystal garden.